And also, Ahmed, thanks again for honoring our invitation again. Okay,
It's a
so
pleasure.
let's start. So, good day, everyone. Good day, good evening, wherever you're in the world. Welcome to another Power BI section brought to you by UrBizEdge. So, for today's session, we're having data modeling in Power BI, and our special guest is Muhsin Hameed. So, this session is brought to you by the collaboration and partnership between UrBizEdge and Enterprise DNA. So for some of you that might be interested in Power BI, Enterprise DNA is an organization that also offers all this training, and their main motto is basically empowering Power BI users to change their world using data. And also, I want to make a big announcement to our new sponsors, which is the MHS Analytics. So MHS, they're also based in Canada, right? So they specialize in Power BI, Excel, and financial modeling. So for some of you that might be in Canada and might be interested in taking training in Power BI, Excel, financial modeling, big data, also Python using data analysis and SQL. You can also check out MHX Analytics. I will drop the link in the chat box. So one of the main goal is basically they're committed to giving their clients the business intelligence edge they need using tools they already know, tools like Excel, Power BI, Python, and SQL. And for us, UrBizEdge, we're a registered Excel consulting, financial modeling, business intelligence, data analysis, and also enterprise solution firm in Nigeria. We specialize in helping companies and high-value professionals be on top of the business data. We're also the developer of some Microsoft tools which you can find on Microsoft Office Store, such as the Nigerian Finance Market Analysis tool, which is available on Microsoft Office Store. We're also a developer of the Nigerian Stock Analysis Dashboard and so many other ones you can also find in Microsoft Office Store. We're also a training company. We have branches in Lagos, Abuja, and also in Port Harcourt. On the 11th, our next training is going to be on the 11th of April, which is Python for data analysis. On the 14th of April will be in-depth Excel training, executive dashboard, and business data analysis. And on the 17th of April, we're having financial modeling and financial planning training. So our special guest, Ahmed Rai, is a certified Power BI analyst and also a certified Microsoft trainer, that's an MCT, is skilled at data ingestion, cleaning, modeling, and transformation of raw data into information and ultimate glancing from insight that could be enable better informed business decision. A business intelligence analyst with over 3 years of working experience with a background in nonprofit and consulting, advocate for business processing improvement. He has passion. Is passionate about deploying low-code tools for identifying and automating manual and media business processes. He's also passionate about community and peer development. He's currently acts as a project manager with the Power Platform User Group Nigeria, where he engages in stakeholders in planning, executing, and coordinating the community activity. So no further ado, I'll hand over the session to our special guest. So I'll stop sharing my screen right about now. So over to you. So Ahmed, over to you. Okay.
All right. You can see my screen dive.
Yes.
Okay. Thank you so much for the warm reception. Thank you everyone for joining the session, and good evening to us. If you're joining from Nigeria, good day everybody on the call. Today we want to talk about data modeling in Power BI. I want to validate some assumptions very quickly. So before I go into the actual discussion, please, everyone, I want us to go to the chart. Just a way to understand what the audience is like. If you have used Power BI before at all, please type a yes on the chart. If you haven't, type a no. You have used Power BI before, please put a yes on the chart. If this probably would be your first exposure to Power BI, type a no on the chart. Okay, I see yes. Okay, yes, all right. Okay, pretty much it. We all have used Power BI before. That's expected, but sometimes it's very much important that you validate whatever you're assuming when you are on calls like this. Great. So today we want to talk about data modeling in Power BI. Data modeling essentially is one of the key things that we need to do whenever you want to analyze data. So analysis as a life cycle, just like everything that so exists. Human being has a life cycle, probably from the woman conceived, then giving birth to, then toddler, then teenager, then adult, then probably death afterwards. So there's this life cycle for most things. The same thing is applicable with Power BI. Power BI has a life cycle for whatever analysis you're doing in it. This life cycle is such that it's not limited to Power BI really. Some other tools you would be doing almost the same thing. And when we talk about the data analysis lifecycle, most times you'll be starting with your data ingestion, which means your data is sitting somewhere. You want to bring your data into the tool you want to use. And after that, you do some transformation on it. Then you want to go on to do some data modeling. And after the modeling, you do your visualization, and probably you want to share your report with people. So most times, these are the major things you'll be doing. There might be some sub steps in between that you may want to go through at depending on the complexity and depending on some requirements that you're getting. But today we want to talk about the midpoint, data modeling. What does it mean when we say data modeling? We have used Power BI before. Probably we have done some modeling before in Power BI. I want a few of us to just type on the chat, what's our understanding of modeling? When somebody says modeling to us, what comes to our mind? Please put that on the chat. Very straight to the point, a summary, not something too lengthy as such. When somebody says modeling to you, or your understanding of modeling, what is it? Put on the chat, please. I'll allow some seconds. I know it might not be so fast to type in, but we need to set a bit of things around that. So what does modeling mean to you? Okay, Oladimeji, putting Excel functions together to build an automated report. All right, thanks a lot, Dimeji. A few more responses. What do you think? To you, what is modeling? Separating data from one another by grouping them differently. Thanks a lot for that, Okwemi. Kuban, changing input and having dynamic outcome. Interesting. Creating relationships between tables. Thank you, Luau. I think I got that. Okay, so they creating relationships between data. Excellent. Thanks a lot, everybody. I'm not saying something is wrong. I won't say something is right for now, but as a matter of fact, this is why we're here. So in a way, we are going to be able to clear certain misconceptions around data modeling. We'll be able to set the foundation right with certain things, and we'll say some practical aspects of this presentation today. What we'll be looking at essentially is this. I'm going to set a bit of foundation as to some things that I expect that we should be aware of. We'll talk about what schemas are. What do we mean by schemas? Probably some of us we've heard about it a couple of times before now. You know, you're conversing with some people and somebody mentions schema. What does it mean? What does it imply? What is the technicality behind it? We're going to have some conversation around that. Then how do you build a data model? Now you are right within Power BI, you want to build a data model. How do you do that? What would be the thing that would influence your decision of what to choose as a particular data model schema to use? And what are the do's and don'ts of data modeling? Just a few of them. This is meant to be a very lengthy conversation because of the fact that when we talk about modeling can be seen in different facets. So modeling a way could be that you're looking at it from the angle of a database administrator, somebody managing databases. The way they see modeling is quite different from the way analysts would see modeling, but this conversation will restrict it to the way we analysts would see modeling and how we should go about building our data model. So now let's go in. When we say data modeling, this is the definition by IBM, and I'm going to explain some key things in this definition. IBM says that data modeling is the process of creating a visual representation of either a whole information system or part of it to communicate connections between data point and structures. This is what IBM said. The key things in this definition: one, visual representation. That is one key thing here. The other key thing here is connection, and we have the third one to be data points and structures. What does this all imply? Let's start with the last, data point and structures. Data point implies that what are the data elements coming from your different tables. So you have a sales table, for instance. On your sales table, you have different columns there. It has those columns, they are your data points, they are your data elements there. The structure of your table, it's also of importance here. What kind of table is it? This we'll talk about it a bit when we get to the later part of this conversation, where we'll be talking about some terminologies that would set the pace to certain things that we'll do in the demo as well. But essentially is just start to imagine this. You have a table, you have some columns on that table, those are your data points. Then you are not now relating with a single table anymore. You want to build a report on top of a sales table, and there's a budget table. You have a sales table, which is a transaction table, and you have a budget table. These two tables now, you want to build a report on top of them. Then you need to think around a connection between these two tables. How can you make these two tables speak to one another? They are disjointed. They are locked. We need to open up the locks and then allow them to talk to one another. And lastly, when we talk about data modeling, is to have a visual representation of that, which means that what we are looking at is a visual representation of it. It's not essentially what is in play. It's not the raw data anymore, but you want to have a visual representation of the two tables you're looking at. I'm saying two tables now because we're considering two tables. It could be more than. So you're looking at two tables. You want to see how they are connected, and you want to see what data points are they connected by. So that is all about data modeling. So data modeling, you're doing three things. You are looking at your data point and how to connect them, and then that will result into a visual representation of what it is that is connecting the two tables and how they are connected. A data model, of course, is just the pictorial representation of that. Terminologies. We talk about keys. We talk about primary, foreign, keys, fact file, and dimension files. But we're not going to go in depth into all of this for now. I want us to start something first, which is how do you build a data model for your report or your analysis within Power BI? But I want somebody to note this. I want us to note this so when we get there, we begin to pinpoint them and refer to all of this terminology. So we know that there is something called key, okay? And your key could be primary or foreign, all right? Then we have something called a fact file. We have something called dimension file. All right. When we want to build a data model, the first thing is this. We need to ask ourselves the question, why should you have a data model? We already understood the technicality behind the model, which is the fact that you're trying to create a sort of a connection between two or more tables, having that visualized. So you see what sort of connection happens between them. But a question would arise. But I want us to go to the chat to answer this first question before I go to the next. Do you need to create a data model? Do you need to do data modeling for all analysis? Let's go to the chat, yes or no. Do you need to do data modeling for all analysis or reporting? Yes or no? Okay, Opayemi said no, Victory no, Peter no, Latifa no, Seleka no, Kuban no, Kende no. Okay, all right, we all said no. It will have been so quick if probably we are able to have somebody speak to this, but it's fine. Yes, we do not need to create a model for all for all reporting or for all analysis that we're doing. But I want somebody to go quickly to the chart. Why do we think, or what is the scenario whereby you probably would be fine with analysis without creating a model? What is that scenario? Just paint something quickly. What is that scenario that you would just be fine without creating a data model for it? 30 seconds. Just type something on the chart. So while you're doing that, I'm going to bring up the data set that we're going to use for this, and I'll show us a few things. If the cardinality is 1-to-1, okay, if there's only one data source, Barnabas, all right? Thanks a lot for that. A situation could be that you have a single table. I'm calling it table, and we understand that a table might just be the source itself, the data source itself. Of course, from a data source, you can have multiple tables. So I want to say tables because so that we don't begin to misconstrue certain things. We have a table like this transaction table that I have on my screen. This table here, if you want to analyze this data here, you may not necessarily need a data model. You may not necessarily need a data model, which means your analysis might run just fine without a data model. But we need to bear in mind something. Part of what we need to bear in mind is this. For your analysis to run fine on a single table, which means your analysis is fine with the consideration of performance. So the performance of your report is optimal. One of what you need to bear in mind is that you do not have a very large table as this. So if this table was running into a million or millions of rows, then you shouldn't build a report on top of it like that. But on this table, I have just 20 rows of data. Just 20 rows of data here. I can go on to build a report on top of this without modeling things. This will just be fine because I have considerably small size of data. But now, assuming that we have a very large data set, which is the first point that I'm going to make about why you should have a data model or why you should do data modeling before you go on to build a report. The first reason is I have a single table like I have on my screen, transactions, and I want to build a report on top of this, but because this is large or this is expected to grow at probably geometrically, then I need to break this table off into normal sized table, which is the concept of normalization and denormalization. So I want to break off a single large table into bits, relatable bits, some bits that business understand, not bits that's only understandable to you. The business needs to understand the bits that you're breaking this off into. That is the first reason, which is I have a large table and I want to break this down into smaller bits. First reason why you should have a data model. Number two reason why you would want to have a data model or you want to model your data is that your data is coming from disparate sources, or your data is coming from the same source, but with a number of tables. Like we have on this Excel file, if this workbook is what our analysis would sit on, which means we have a table called transaction, we have a table called model cart, we have a table called sales, and like that, and we want a single report on top of all of these, then essentially we need to model our data. Let's go to the chart quickly, everybody. I mentioned two reasons why you should model your data. Please, let's put that on the chart. Why should you model your data? Put on the chart. Reason number one, reason number two. Quickly on the charts. I'm sure we haven't forgotten. Let's say the first to have an input here. Thank you, Dimeji. When there is a large data, of course, a single table, you have very large data there and more than one data source. Excellent. Kuban disparate sources breaking into meaningful places. Perfect. So now we're going to be looking at a couple of scenarios, but let's begin with this. Assuming that this is our very large table. Thanks a lot for our input. This is our very large table here. And then we want to model this table. Meaning, we want to break this table down into meaningful bits. How do we go about that? So the way to go about that is very simple, which is we're now talking about the data modeling steps. So these data modeling steps, I'm going to run through them practically. So we see how to go about them practically, and that probably would be a way to guide you in some other assignments that you don't want to go through. Step number one is this process is saying that you need to list out all your reporting fields. What does this mean? There are a lot of jargons here. I'll make them closer. I will bring them closer to us. So let me go on to my Excel file. I have a sheet here that I've called model. So what is step number one is saying is this, is that list out all your reporting fields. What are your reporting fields? They are typically your column headers. Your column headers are typically your reporting fields. So I'm going to come here, I'll highlight the entire columns, I'll bring it, and then I'm going to paste it here. So these are my column headers here. So that is the first thing I will list out. So region, market, store, and all of these are the column headers. Step number one, we have done that. Step number two is saying that we need to now group those fields, those reporting fields that we have highlighted from step number one. We need to now group them into categories and values. Before I go into grouping them into categories and values, can somebody go to the chart and type what are the kinds of data that you have? What are the kinds of data? So we're speaking a bit of statistics here. There's a way they group data into what and what. I think it's just two. What are they? Let's type on the chart. So Shegun said I usually use a pivot table to break a large data set. Is that all right? So when you use a pivot table, you are typically summarizing your data. And of course, that would work just fine for data that Excel can accommodate in a way. But you know, for your Power BI, you don't have a pivot table there. So it's a different experience in its own. And we need to now do some things differently. Thank you for that, Okpayemi. We have qualitative and quantitative data. Qualitative data and quantitative data. Perfect. What does quantitative means? Quantitative from quantity. So whatever you can quantify, think about it as things that you can aggregate on your data. So we are looking at our data like this. Of course, you can aggregate the column of your revenue. So this column of your revenue, you can aggregate it as it is. You can aggregate this column of your units sold. But the other side of it is qualitative data, which means you can't aggregate it to make sense, really. So essentially, it's about categories. That's the same thing we are talking about in step number two. So you are to group the fields into categories and values, which means group the fields into qualitative data and quantitative data. That is essentially what we're talking about here. So I want us to identify that for me. On this particular report fields that we have here, so we have region down to units sold. Which of these do you think it would make sense to perform aggregations on? Which of them? Can we quickly type on the chart? Which of these would make sense to perform aggregations on? Okay. So revenue and units sold. Perfect. So revenue and units sold are the fields that you can perform aggregations on. So they are your values. So you remember we are splitting this into categories and values. So I'll just put a V to identify them. So revenue and units sold, they are your Bs. So every other thing that you cannot aggregate, just see them all as your categories. So we call them a C. So we now have a C and we now have Vs. Step number 2, done. Step number 3, it says that we should now look at our categories and put whatever would form a natural hierarchy, we put them together. What does this mean? This simply means that we are looking at our categories, our C's that we have here, that's what we're looking at, and we are trying to group related elements together. We are trying to group related elements together. What does related element mean? It means that if I'm looking at my region, for instance, my region from my data speaks about, it says North Central. And within that region, we can find a market called Federal Capital Territory. This will be very much relatable to those of us that we are in Nigeria. So which means, in a way, your region is related to market on this data set. So that is what we're trying to do. So we are looking at our entire C's, and we're going to put together things that are related. So let's begin. Which of these are related? Let's type on the chart. I've given us an example. I see that region is related to market, and again, somehow it is related to store as well. So region, market, and store, they are kind of related. So tell me the remaining ones. So these ones that are related, I'll call them D1. Which other things are related here? Which other things are related from the C's? Remember, we are dealing with the C's. Okay, thank you, Payemi Region Market and Store. I saw that. Okay, Cuban dates. Okay, what are the dates? Trade dates, delivery dates. All right. Is there any other thing that's related to the trade date and delivery date? All right. Barnabas added fiscal period. Excellent. Is there any other thing that is related to that? To fiscal period, what again is related to it? I see something else. So I want us to figure it out. Day category, perfect. So these, I'm going to call this D2. And then, okay, I would extend it to this. And I would also give my day category D2. So now, the remaining two here, just so to be fast, model and line of business, they are not related. So I'll call my model G3 and my line of business, I'll give it a G4. So step number 3 is all about our categories, which are the C's. That's what step number 3 is talking about. So we are ignoring V's. Step number 4, what does it say on our data modeling steps? It says now that we should now go into each of those groupings that we have done. Remember that we now have groupings for D1, we have D2, we have D3 and D4. So we now look at each of the Ds. So we look at D1, for instance, and we try to get which one has the lowest hierarchy. Which one has the lowest hierarchy? Sort of saying the lowest granularity there. What is it? From whatever dimension we have. So I'll come here to D1, for instance. Somebody should figure out which has a lowest hierarchy here. Region, market, and store. And by lowest hierarchy, what we mean is, what is that little thing or the littlest thing that when you know it, you will be able to access every other thing within that dimension. Perfect is the lowest thing here. So since the store is the lowest thing, then we're going to tag our store. We target something like the key. You know, we are giving it the key. That is the key that will grant us access to the D1 dimension. So which means once I know a store, I should be able to know what market that store is in, and I should be able to know what region that market is in. So that is the key to it. So let's go to D2. We have trade date, delivery date, fiscal period, and day category. What do we think should be the key here, the lowest, the item with the lowest granularity? Okay, I see somebody mention day category. I see delivery date. I see day category. I see day category. Excellent. Let me assist us a bit here. Thanks a lot for that. I see trade date. Perfect. Well done, everybody. So now, a way to know is this. Let's go to our data to see. For this first transaction, for instance, this very first transaction here, we have the trade date to be the 1st of April, 2014. The delivery date was the 3rd of April, 2014. And then we have the day category to be a work day. So for our day category, it has just two options, which is either a work day or public holiday. So if you're looking at day category to be the key, it means what we are saying is that once I know the day category, I would be able to know the trade date and the delivery date. I think that may not be too correct there. So because day categories seem to be higher, we need to know the trade date or the delivery date before we can now say that, okay, this happens to be a work day or this happens to be a public holiday. So in this instance, our key can either be the trade date or the delivery date. That's the lowest thing here, because every trade date will belong to a fiscal period, okay? And every trade date would have or will belong to a day category. So the same thing is applicable to the delivery date. So let's just go with the trade date for this case. So for trade dates, I'm going to pick that as the K. The ones that are just 1 in their category, my model and line of business, they are the key to themselves. So this is a single door and a single key must open that door. Okay, so we have this to be this. Step number 4 is done. Step number 5 is saying that you need to now identify your fact file. What does fact file mean? I'll come to that. But what this step is just saying is that we're now going to do an aggregation of all our keys. We're going to aggregate all our keys as well as our V's. That's what we are doing on step number 5. So everywhere that we have key, that we have keys, we pull them there. So those are the keys to somewhere. I'll talk about it. And then we also bring forth our V's. So our V's are here as well. So this is step number 5. And let's begin to talk about our terminologies. So now in all of this, we have seen something called dimensions, and we have seen something called the fact. What does dimension mean? Dimensions are attributes. That is what they have. So when you are modeling your data, you would have two kinds of tables, essentially. Two kinds of tables. You have your dimension tables and you have your fact tables. Your dimension tables, they are your tables with attributes, tables that contain attributes. That's what your dimension tables are. And your fact tables, they are your transactional tables. What does it mean to have a transaction table? It means that a table that houses your entire transaction, all forms of transactions that you have. That is the table that houses it. That is what a fact table means. So which means that on your fact table, you expect to see a sort of a daily transaction. You expect to see columns that can be aggregated. You expect to also observe or experience a growth in that table. Those are attributes or those are properties or features of your fact table. But when you talk about your dimension tables, they are just mere attributes. And one of the key features of that kind of table is that the table is not expected to really grow as fast. Okay, your dimensions are not usually changing every time. So for instance, we have a product table. Or your product table, you'll be having columns like product name. You could be having columns like product category, product subcategory, product color, product size. All of these are attributes of products. It is not every day that you introduce new product into the market. So which means that it could happen that your product table, which is a dimension table, might not change for years. But when we say something is a fact table, it's most likely going to be changing every day, except for probably you don't run your businesses on weekends or certain days. And it is expected to have columns that can be aggregated. Those are the differences. So in these data modeling steps that we have done now, we have splitted our transaction table here into a number of tables. Let's figure them out. What are the number of tables we have here? All our Ds, they form separate tables. So if I pick my D1, for instance, my D1 is a table on its own. D2 is another table. I think I have D3, and then I have D4. So I have 4 Ds, 4 tables here. Then I have a table that I'm going to call F, which is the 5th table I'm having here. My D1, what do I put on that D1? Everything that I've tagged as D1. So these 3 guys, I tagged them as D1. So I'll put them here. Then for my D2, I have these guys here. So I'll put them here. And then I think I have something else, the category. So this all forms my D2. My D3, I have the model, which is the loan guy here, and D4 line of business, which is the loan guy here. And for my F is everything that I have under step number 5, which is I'm going to pick my store and trade date, pull down under F, and I'm going to pick my model and line of business. I'll pull that to F, and these 2 V's, I'm going to pick them as well and drop them under F. So that is all I'm doing. So what are my D's and what are the F's? The D's I will see here, they are my dimension tables, and the F here is my facts table. And again, I said facts table must have columns that can be aggregated. This is expected to grow almost every day, probably every hour, every minute. Date will continue to grow, and you'll be recording transactions based on revenue and whatever you're selling. But these guys here, they are not expected to grow as quickly. They are not expected to have duplicates because they are just attributes. So we are done with our data modeling. We have modeled our data. This is the rough work. This is the most important thing, which we have just completed. So let's go into Power BI now and see how we can now exemplify this on our Power BI itself. So I have a Power BI file here. I'm gonna come here to the Home tab, and I'm connecting to, there is where is that, my data. So I think it's on downloads, data modeling in Power BI. And remember, I want to bring in my transaction table. So that's all I'm bringing in. This data is clean, so I will not do any transformation. I'll just say load. So I'm loading this. I've loaded this into Power BI. So this is a single table which I can work with. But again, remember that you want to model this, you want to break this all off. So I'll come back here. I'll bring up my Power Query editor to do exactly the same thing that I've done on paper, which is now split the table into 5 tables with these columns that we have identified. So I'll do that pretty quickly here. So I'm just going to duplicate this table. I'll duplicate it 5 times or 4 times. So I have 5 tables here. Duplicate, and I'll duplicate as well. The very first one, I want to use it for my D1, which is we should have region, market, and store. So I'll come here, I'll say choose columns, and then here I want to have region, market, and store. That's all I need. I'll do OK here, and I'll highlight everything like this, do a right click and say remove duplicate. So that's all I need for this. So I have a D1 table here. So I'll just give it a reasonable name. So I can call this D, probably D location or something like that. This all speaking to location. So I have a single dimension. That's D1 already done. So I'll come here. I have a D2, which has all my dates. That's all I have on my D2. So I'll come to the second table here, duplicated. I'll do choose columns, and then I'll select trade date, delivery date, day category, and what is it again? Fiscal period. I'll do OK, and I'll do remove duplicate as well. So I'll call this the dates. Then I'll come to the third one, model. That's the only thing there. So I'll come here. choose columns, US model, select model, and I'll remove duplicate from this as well. And I'll call this D model. Then the next one should be D4, which is the line of business. So I'll do choose columns again, and I'll select line of business. Then I'll remove duplicates from this guy, and I'll call this D line of business. And the last one should now be my fact table, where I expect to have store, trade date, model, line of business, revenue, and units sold. So here I'll go here, choose columns. Then I need the store, trade date, model, line of business, revenue, units sold. Okay. All right. So here I can call this my, I'll just remove the other things here. So it's still my transaction. And again, because this is my facts file, this is your transaction, you shouldn't remove duplicates from this. If you remove duplicate from this, you lose some of your transaction. So we'll leave this as is. Our dimensions are what we'll remove duplicate from. Once you have built out the exact thing that you did out of Power BI, then we can do a close and apply. And now this will load our data back into our Power BI. So we have this here. I have some tables here. I have a table here. So this is the model view of Power BI. We all do know. And here I have the 5 tables, already seeing a sort of a line connecting the different tables. Remember our definition of a data model or data modeling, which is essentially that you're trying to look at data points from different tables, establishing a connection between them, and visualizing the representation of that. Exactly that definition is what we can see here. This is the visual representation of what is coming from our data source, which is what we can see here now. But again, a couple of things to quickly note. If you look at these individual tables, these 2 tables, the location and transaction, that is a line between them. And the line is using something to connect with it between the 2. On the delocation table, your store column is connecting to the store on the transaction table, which then is what is called the key. The key is what establishes a relationship between 2 different tables. And it is via that key that you'll be able to access elements from a table on the other table. We have 2 types of keys. We have the primary key and we have the foreign key. Whatever table has unique items for the key column, that is your primary key. And whatever column has multiple items, that is your foreign key. So now the primary key here is our store on the delocation table because we have a one side to it, which means that one side means that you have unique values there. So that is your primary key. So that same key on the other table, which is the transaction table, is the foreign key because it is on the other side of the table and as well it has duplicates. So that's the concept of primary and foreign key. Primary key, it is unique. Foreign key, it has duplicate on another table. So let's do something here. If I come here and I try to build a report here on this table, if I try to do a report of, if I go to my date table and then I select my trade dates and then I come to my transaction table and I pick my revenue. Immediately, we see that something is wrong. My revenue figures for individual dates, they are the same across board. The very first thing that should come to mind is that this is a data modeling issue. And always remember the definition. That is why for me, I advise people to understand concepts before the how-tos. So you need to understand the concept first before you go into how to do that thing, which is the thing of what is data modeling. Data modeling is trying to establish a connection between 2 tables so that they can talk to one another and they are able to retrieve details from one another. That is data modeling. So now that we have a table that is meant to visualize something coming from our date table and our transaction table, but we are getting the same result across board. the first thing that comes to mind is that these two tables are not talking to one another. And then we need to go to our model, and that is what we just see here. So our due date has no connection to the transaction table. If I go on now to say that I want to build a relationship between these two, there are a couple of ways to do it. But very quickly, what we'll do is whatever you have identified to be your key, which is our trade date in this instance, I'll pick it, then I'll drag and drop it on the trade date on the other table. When I do that, it tells me now that there is a many-to-many relationship. What does this mean? And I'll use this to quickly explain the cardinalities. Cardinality is about the kinds of relationship you are creating between two tables, which is what is the granularity between the two columns involved. When I come out of this, for instance, if I come out of this, these two tables here, they have a one-to-many relationship or many-to-one. Many-to-one and one-to-many, they are the same. It just depends on the position of the table. One side of this, which is on the store here, the D location, the store, implies that I have unique items here, but I don't have unique items on this other side. That's why I have a many-to-one. So the same vein, one-to-many. One-to-one means that on both sides of the table, they are unique. The columns on one side of on table A, that particular column that forms the key, they have unique items. On table B, that particular column also have unique items. That's when you have a one-to-one relationship. But this is a relationship you always you don't really use. Okay, so when you have one-to-one, you can turn it to one-to-many instead. And many-to-many means that on both tables you have duplicate values. That's what it implies. So what we'll do to this is that we can quickly go and edit this query. But again, you have to be careful with what you do. What typically we want to do on this is that this column that says trade date will remove duplicate from it alone. Of course, that would affect some other things. Ideally, when you're building your actual report, you are not using a date table as such. You want to create your own calendar table. That way you will have a unique table across board. So when I do this, I close and apply. That will resolve that issue. And then now I can pick my trade dates and I drop it here, and now I have a one-to-many relationship. I come back here, my report is resolved. So now I come here again. What we see here, the visual representation that we see here, this is called a star schema. When we talk about schemas has to do with, if I got that correctly, somebody said that they cannot hear me. Please, can everybody or anybody still hear me?
You're
Please, can we
audible.
confirm that on the chat?
You're audible.
All right.
You're audible.
Thanks a lot.
You can just leave and join again.
All right. Thanks a lot. So now, schema is about the arrangement, the picture that we see. I know there is a particular term they use for it in database terms, but I can't really recall that for now. But now, when we talk about schemas, essentially, we are talking about, for Power BI, we are talking about your star schema, or we're talking about your snowflake. There's other one they call a galaxy schema. So, but the star schema and the snowflake, they are the most common. So what does the star schema mean? It's just about the arrangement of your dimension tables around your facts table. Remember, your facts table is your transaction table. How are they arranged? How are they related, connected in a way? So the connection that we see here is a star schema. This forms something kind of a star. You know, you're looking at, this is like the shape of a star, something in between, and it has arrows all around it like this, which means all your dimension tables are meant to go and filter your facts table. That's what this means. But let's do something now. So I'm going to connect again to my file, data modeling file. And then here, I would select my, I think it's model card table. Yes, model card table. Somehow I will need to quickly transform this because the header is not appropriate yet. So I would just do, where's my promote header? So I'll promote the headers so that the header sits where it's meant to be, and then I'll close this. When I do this now, immediately we see that we have another kind of relationship coming in. Let's look at this on the Excel file so we understand. So I have this as the transaction table, and I have this as the model cast table. What the model cast table is doing is essentially looking at our models. So these are the models that we have on the model column, the unique items there. And we have it another category within the business that we have put each of the model into. So whatever model ends in P, we call them printing. Whatever ends in C, we call them copy maker. Whatever ends in T, we call them tractions. So now, when you have another dimension like this, come onto your model. And the way you want to build this out is to do something like this, such that you have a model, a dimension rather, connected to another dimension before that flows down into your facts table. Then this becomes not anymore a star schema, but something else. But before I go to that, I mentioned earlier to us that we have three kinds of relationship. You either have the one-to-many, which is the same as many-to-one, or you have the one-to-one and you have the many-to-many. So this is a sort of a one-to-one relationship, which is on both sides of the table, we have unique items. So what I would do is I can leave it at this. It doesn't matter really, but I'll just change this to one-to-many. And I would also want to change this from both to single. So I want the model cards to only filter the D model. So what we have do, this kind of model now, this kind of schema now, is no longer a star because there's an extension to our star. And this is what is called a snowflake schema. A snowflake schema is essentially a star schema with an extension into another model or multiple models, such that those models will filter down into a particular, such that those dimensions rather will filter down into a particular dimension before the filter is now propagated into your facts table. This is what this would mean. So I'll go to my report view. If I come here, I can go onto my D model. I'll select my model, and then I select units sold, for instance. So these are the units sold for this particular model. What your snowflake would do is if I add, there is a slicer. If I add a slicer here, I need to close this out now. So if I had a slicer here and then I go to my new table and then I select my model category. So here we have three model categories. So if I select copy maker, you notice that it filters down my dimension, the model dimension, into the dimensions that have C's, items that have C's, which is what this particular model is doing. So whatever you are selecting here will first filter down. A filter will be propagated down to the model. So on this particular table, the only thing you'll be seeing now will be based on the selection at this level, and that would then be propagated down to your transaction table. So I think this is a good point to stop. Like I mentioned, this is usually a very lengthy conversation, but I have a couple of other things that I would actually have loved to mention, but because of time, so I think we should stop here. Maybe some other times we can have a part 2 of this to discuss more about the snowflakes dimension. We discuss many-to-many relationships, how to handle that, and a number of other nuances around data modeling. Thank you, Temida.
Awesome. This is really rich, very rich. Okay, so if you have any question, you can raise your hands up. Okpemi is asking, did you remove duplicate again from the column? Okay, let me just make Okpemi a speaker. Okay, I think he's even raising his hands up. So let me just make him a speaker. Okay, so Okpemi, you can mute your mic and speak. Hello, Okpemi, you can mute your mic. Okpemi. His hands are still up. Okpemi, you can mute yourself and speak. Okay. If anyone else has any question, please you can raise your hands up. But awesome. This is very rich. It's very rich. Any other question? I don't like the way you broke it down. Very interesting.
Hello.
Okay, I think. Yeah. Good evening, Mr. Okwe.
Good evening.
Good
Please,
evening.
I want to ask this question. I put it on the channel already, but let me put it straight here. I've
Okay.
encountered a lot of problem like this that when I want to connect from fact table to one dimension, it will force me to do many to many. So, and I know that it's not proper. So, when the instructor was about to do it, to correct it, then the network was break. That's why I text them. So I don't know how he changed it from many to many to one to many. That's the first question that I have for him.
Okay.
The second question is that there was a day I was discussing something like this on Twitter. So one guy said that instead of duplicating the old table before we now model them, that we can use preference. There's one line like that after duplicate reference that we can click. So I don't know how to use it. If the instructor can explain it to me. Thanks.
Okay. Thank you for that, for your question, Opayemi. Let me begin with the reference bit of things. So if I go here to Power Query, and so I'm here now. So now this transaction table, let's assume that I want to recreate my D model from this. So what I would do is I'll do a right click on this. And then you remember that initially what we did was to do a duplicate. So if I do a right click now and I say reference, the difference between these, I will show us now. So I want to create D model. So I'll come to D model, do a right click, remove other columns. Then I would say remove duplicate. So I'll call this D model ref. Okay, we won't see anything yet now. I'll close and apply. I have a new table, D model ref. Then I'll come here to my Excel. If I come to my transaction table, I'll duplicate this last transaction, Control D. Then I'll come to my model. I'll make this, let me make this something that's not here, ABCD. That's what I'll call this. So this is the model ABCD. I'll save this, Control S. So I've saved this. So let me close this file. I'll come back here. Let me just say to refresh this particular table. Refresh data here. Then I'll come to my data view. So if I go to my D model table, notice that that new model that I added is not here. It's still the actual data here now. But if I go to my D model ref, I have an additional, the new model that I added, which is ABCD. So the difference between reference and duplicate is reference is having a link to the actual place that's to the actual point of initial reference. How do I explain this? Let me not confuse you. What reference is doing is that there is a link to the transaction. So, you know, when we duplicated, if I go back to my D model, when we duplicated, we add all the steps that were from the initial table, we add them all copied down. So that's what duplicate would do. But when you reference, it does not copy down all those steps. And if you look at the source here, the source will be your transaction table. It says equal to transaction, which means whenever there's a change on your transaction table, that change will be propagated down to the reference table. So the only time I see that you might want to be using referencing is when you suspect that there might be changes on the parent table and you want that change to propagate down. That's when you should use reference. But in a way, I'm not so sure, but I think that this has a bit to do about performance as well, because if there's a breakage in your transaction table, of course, this will break. Even when you do duplicate, it will break really. But then you just have to use it sparingly to understand what you want to achieve. So if there is no reason to have whatever change from the parent table propagates down, then there is no reason to do reference. So that is referencing. Then your first question about a many-to-many relationship. That is part of the don'ts from data modeling. You shouldn't do many-to-many relationship. It is something that I would have loved to. I had a plan to also speak about that, and that's why I have these two tables that I brought in. But that may take a bit of our time, and I know that we might have some other questions too. But essentially, is a way to manage many-to-many is to do what is called a bridge table. You bring in a bridge table, and then you use that to manage the many-to-many. So there is also some talks around cross-filtering and stuff using both. That is when you set your relationship direction to both. Those are things that you need to avoid, and there are ways to actually manage them. Probably we have another session to discuss some of those. Temida, do we have any other question?
Okay, so someone's asking that, do you usually use snowflakes to add additional slicer?
That's not typically the reason to use snowflakes. So what normally happens is, you're building a data model based on the business requirements. Business would explain to you that this is how we understand our data, and you're building a data model out of that understanding as well. So now, typically what might happen is you have a single dimension for model, but that dimension file seems to be very big. I want to break it off as well. Maybe in that dimension, you have the model name, the model category, the model subcategory, the model start dates, a lot of attributes on that. So you may want to break that dimension table into 2 or more. So when you break them down into 2 or more, it eventually will give you something like a parent-child relationship, such that something would have an higher level, and then the other dimension will be at the lower level. Say that you have a model category. So from the model category, you have some items there, some attributes. There's another table that says model subcategory, which has some other attributes. So your subcategory is typically under there is a kind of a relationship between them. So when you bring them into your model, it actually depends on how you want to handle your reporting. You might want to connect both dimensions directly to your facts, but sometimes that is not what you want to do, because you need to find a way to join the 2 tables back. And the way to join them back is to do snowflaking. That's exactly what you're doing when you want to join them, because this way, these 2 tables have been, these 2 guys, they have been joined back, and they can talk to one another this way before they now begin to talk to your facts table. And again, is that if we have these 2 tables speak to the facts, it means that we would be able to create report based on the attribute from individual tables. There is no way we'll be able to combine attribute from these 2 tables to create a single report. So which is a reason why you want to do snowflaking as well. I hope I answered that question.
Very clear. That's very clear. I don't know if person. Okay, I think he has commented. Yes. Okay, he said thank you. Yes. Awesome. Okay. So also this session, I know you had a lot to even talk about with your many-to-many and other kinds of relationship. Okay, so our last 2 questions, right? But if you still have any question, you can raise your hands up, or you can put it in the chat box. I'll read it out. So our last 2 questions are made, right? How you started your old data journey, and also what advice for people just starting out in the data field?
I started my data journey. I would say that a little background here. I studied mechanical engineering, and almost when I was rounding up the program, probably my 400 level, I went on IT. And when I went on IT, I noticed that I don't think it's something I would want to do for a profession, a career. And the basic reason was the fact that at that point, I had my IT in a power generating firm. And there was a lot of exposure to the exhaust from the turbine. And that's typically something that affects my health. I'm allergic to that. And so I saw that if I would be in this environment, probably my entire salary will be something I'll be using to buy drugs at the end of the month. So I felt I'm not sure this is what I want to do. And I began to think about something else to do. So when I was eventually mobilized for service, I got to be posted to the Ministry of Works in Akwa Ibom State. and they are the Ministry of Works. Probably some of us who we are aware of how things go there. You know, you don't do a lot of work. You just did it. Sometimes you don't do anything. So I was not going at the point. I would sit back at home and then I was researching about what to do. But before then, after school, I started a program with Mandela because I learned about a bit about some tech skills at the point, and I felt that probably something that I could pick up, and then I could do a bit of things in that regard, rather than the engineering that I studied at school. So I applied to Mandela, the ALC, I think that was 3.0. I was selected to be on the web development track. I was doing that before I was mobilized for service. So when I was mobilized for service, before I traveled, my people at home said I shouldn't go with my system, blah blah blah. My guest port account, my guest stolen, so I didn't go with my systems. So when I got to the camp, after the campaign, I was thinking that, okay, after 3 weeks, I'll travel back home and then I can continue my Andela program. But unfortunately, after campaign, I had to sort a number of things. So sorting those, I think I stayed about 2 months extra before I could travel at all. And when I traveled back home, I got to know that the deadline for the first project was like yesterday. So I got home today and the deadline was yesterday. So that was closed already. I missed out of that. And when you miss some deadlines, like the major deadlines, you are out of the program. So that was the end of my career in development. So I go back and then I said, okay, what else to do? Probably I need to switch track because even the development, it wasn't smiling really. So I wanted to do something else. Then I started making my research. I stumbled upon some things around data, and that was typically how I picked interest in data. And coming from a background in engineering, statistics, and all, so I felt doing something around data might come in very much handy to me. So I picked interest. Then back on my service year, I was taking some courses on Coursera, EDX, and all, doing some Excel training there. And at the tail end of it, I took a Power BI course as well. And after service, after some months, that should be about 3 months, I went into a program first. Then after completing that program, then I got an internship with Dibran Consulting, where I currently work. Although at the start, it was meant to be a Power Platform internship, but eventually, Power Platform, it has a number of data things within it as well. So Power BI is a member of the Power Platform family. So that's why, in a way, I got my hands on Power BI practically now, not the learning side of things. And that's how the whole journey began. That's the first question. I'm not sure I can remember the second question.
The second one was, what advice about people just starting out in the data field?
My advice would be that I know starting out will be very difficult, most especially in this information age. There are a lot of information out there for you. If you go to Google and you type how to become a data analyst, I'm sure you get tons of information there. You will get confused. So what I would say is that, which is probably a mistake that some of us made, is that speak to somebody doing that thing. Go on LinkedIn, search for people that are data analysts, check for their tools, the tools they use and stuff, the industry they work in. Of course, you may have interest in certain industries. Don't speak to anybody, just anybody. Streamline who you're going to speak with. So if you want to be a data analyst, probably in the energy sector, go on LinkedIn, search for analysts in that sector, speak to the person. That if you're going to start out today, how would you start out? The person will give you a clear roadmap, a practical roadmap. And that's what I think would assist you in this age. Not you going on YouTube or going on Google to type for things. You get tons of information, you get confused. You just be jumping from one resource to the other. Streamline the entire thing before you begin. Speak to an expert. Let them advise you on what to do based on 2 things: the role, the path you want to follow, the data analysis path, and if you could also streamline it to industry, because sometimes industry play a major role in what tool and the kind of things they need to learn. So streamline it to those 2 and use that to search for people in that space. get advice from them, a clear roadmap as to how to go about it, but don't bug them with too much messages. I know that's why some people will not respond to you. So just make it straight, get a clear roadmap, and live up to that. So it's only if they advise otherwise during the course of the journey, that's when you should change your course. Otherwise, I think you should just stick to that, and I'm optimistic that you'll be fine.
Awesome. That's amazing. That's a lot. I think I actually have almost the similar part. And I miss Siri. I miss Siri.
I miss hearing it.
I also served in Akwa Ibom.
Oh, interesting.
Yeah, I also did electrical engineering. Also had the same situation. I never served. I just stayed at home learning data. Okay, so awesome. That's really a lot. That's a lot. Thank you so much. Definitely, we're going to have another part because of it. You said you're going to take us take the star schema and everything, So, and the snowflakes and the rest. Okay. So it's asking that. Did you attend OAU?
No, I did not. But I had a brother that